Now, let's say about fourth unit of operating system is memory management. This unit contains background of memory management, swapping, contiguous memory allocation, segmentation, paging, virtual memory, demand paging, copy on write, page replacement policy, FIFO, optimal, LRU, allocation of frames, and threshing. Let's say about one by one. How background of memory management. Memory management is the functionality of an operating system which handles or manages primary memory and moves process back and forth between main memory and disk during execution. Memory management keeps track of each and every memory locations regardless of either it is allocated to some process or it's free. It checks how much memory is to be allocated to process. It decides which process will get memory at what time. It tracks whenever some uh, memory gets freed or unallocated, and correspondingly it updates the status. Next one, swapping. When a process is executed, it must have resided in memory. Swapping is a process of swap process temporarily into a secondary memory from the main memory, which is fastest compared to secondary memory. Swapping allows more process to be run and can be fit into memory at one time. The main part of swapping is transfer time, and the total time directly proportional to the amount of memory swapped. Swapping is also known as rollout roll-in because if a higher priority process arrives and wants to service the main memory manager can swap out the lower priority process and then load and execute the higher priority process. After finishing higher priority work, the lower priority process is swapped back in memory and continued to the execution process. Here now, so the diagram swapping. Swap operating system, user spaces, the swapped out, process one and process two swapped in, main memory and secondary memory is the condensed storage data spaces. Next thing, contiguous memory allocations. The main memory should oblique both the operating systems and the different client process. Therefore, the allocation of memory becomes an important task in the operating systems. The memory is usually divided into two partitions, one for the resident operating systems and one for the user process. We normally need several user process to reside in memory simultaneously. And therefore, we need to consider how to allocate available memory to the process that are in the input queue waiting to be brought into memory. In adjacent memory allotment, each process is contained in a single contiguous segment of memory. This diagrams contiguous memory allocations process and memory blocks. Next thing, paging. Paging is a method or technique which is used for a non-contiguous memory allocation. It is a fixed size partitioning theme. In paging, both main memory and secondary memory are divided into equal fixed size partitions. The partitions of secondary memory area, unit and main memory area, unit known as pages and frame respectively. Paging is memory management method. Accurates fetch process from the secondary memory into the main memory in the form of pages. In paging, paging is a memory management method accurates fetch process from the secondary memory into the main memory in the form of paging. In paging, each process split into parts wherever size of every part is same as page sizes. The size of the last half could be also be, but the page size, the pages of process area unit hold on within the frame of main memory, relying upon their accessibility. Properties system, frame on frame to etc. As a page on page to page is a process etc. The mapping pages to frames. Next thing, segmentations. The segmentation is another non-continuous memory allocation scheme, like paging. Like paging in segmentation, process not divided into indiscriminately into mounted size pages. It is variable size partitioning theme. Paging in segmentation, secondary and main memory are not divided into partitions of equal size. The partition of secondary memory area unit as a segment. The details concerning every segmentations are holding in a table known as segmentation table. Segment table contains two main data concerning segment. One is base, which is the button address of the segment, and another is limit, which is the length of the segment. In segment, CPU generates a local address that contains segment number and a segment offset. If the segment offset is smaller amount than the limit, then the address called valid address. Otherwise, it thrown miscellaneous because the address is invalid. Here the 0102 space limit is segmentable and is a physical address, operating system segment 1 and segment 2 is etc. segmentable in CPU serial number offset is logic address. So offset is limit is offset is greater than limit is true. Yes, is the placement no is the invalid address. This diagram shows between the how to flow the data in segmentation. Next one, virtual memory. Virtual memory is a storage allocation scheme in which secondary memory can be addressed as through it via part of main memory. The address program may use to reference memory or distinct from the addresses the memory systems uses to identify physical storage sites. And program generated addresses are translated automatically to the corresponding machine's address. Next one, demand paging. The process of loading the page into memory on demand is known as demand paging. The process includes the some steps follows. First one, if CPU try to refer a page that is currently not available in the main memory, it generates an interrupt indicating memory access fault. Second one, the operating system puts interpret process in a blocking state. For the execution to process, the operating system must bring the record page into the memory. Next one, the operating system will search for the record page in the logical address space. Fourth one, the record page will be brought from logical address space to physical address space. The page replacement algorithm are used for the decision making of replacing the page in physical address space. The page table will updated or accordingly. The signal will be sent to the CPU, continue the program execution, and it will place the process back into ready state. This is the diagram for demand pagings. CPU, the P process move to the bits and then move to the flow, operating systems and page access and page manifestations and the last LAS. Next one, advantages of demand paging. Here, uh, more process may be maintained in the main memory because we are going to load only some of the page of any particular process. There is room for more process. This leads to more efficient utilizations of the process because it is more likely that at least one of the more numerous process will be in the ready state at any particular time. Process may be larger than all of main memory. One of the most fundamental restrictions in programming is lifter. A process larger than the main memory can be executed because of demand paging. The operating system itself loads pages of process in main memory as required. It allows greater multi-programming levels by using less of the available memory for each process. Next, we move to copy on write. Copy on write or simply COW is a resource management technique. One of its main uses is in implementation of the fork system call in which it shares the virtual memory of the operating system. In Unix, like OS fork system call creates a duplicate process of the parent process, which is called as the child process. The idea behind a copy on write is that when a parent process create a child process, then both of these process initially will share the same page in memory, and these shared pages will be marked as copy on write, which means that if any of these process will try to modify the shared pages, then only a copy of these pages will be created and the modifications will be done on the copy of pages by that process, and that's not affecting the process. Suppose there is a process P that creates a new partition Q and then process P modify pages. The figure shows what happens before and after process P and modify page 3. The memory page process P, page and page 2, page 3, before processing P, modify page 3. Process Q, process P, after modifying the process P, modify pages, page 1, page 2, page 3, copy of pages, the process Q. Next one, page replacement algorithm. Page replacement algorithm or the technique using which on operating system decides which memory pages to swap out, write to disk when a page of memory needs to be allocated. Paging happens when a page fault occurs and a free page cannot be used for allocation purpose, accounting to reason that pages are not available or the number of free pages is lower than required page. When the page that was selected for replacement and was paged out is referenced again, it has to read in from disk and there's required for IO completions. And this process determines the quality of the page replacement algorithm. The lesser than the time waiting for pages, the better is the algorithm. Page replacement algorithm looks at the limited information about access the pages provided by hardware and tries to select which page should be replaced to minimize the total number of page misses while balancing it with the cost of primary storage and the process time of the algorithm itself. Next one, page replacement algorithm. Page replacement algorithm considers some first in, first out algorithm, optimal page algorithm, and least recently used algorithm, LRU. First, we see first in, first out algorithm. This is on the oldest page in main memory is the one which will be selected for replacement. Easy to implement, keep a list, replace pages from the tile and add new pages at the head. These are referencing string and misses. The biggest source. Next, optimal algorithm. An optimal page replacement algorithm has the lowest page fault rate of all algorithms. An optimal page replacement algorithm exists and has been called OPT or min. Replace the page that will not be used for the longest period of time. Use the time when a page is to be used. The diagram shows the how to data move in optimal page algorithm. Next one, least recently used algorithm. Page which has not been used for the longest time in main memory is the one which will be selected for replacement. Easy to implement, keep a list, replace pages by looking back into time. This figure shows the how to work the list is written. Next, we will move to allocation of frames. The absolute minimum number of frames that a process must be allocated is dependent on system architecture and correspondence to the worst case scenario of the number of pages that could be touched by a single instructions. If an instructions span page boundary, then multiple pages could be named just for the instruction features. Memory reference in an instruction touch more pages, and if those memory location can span page boundaries, then multiple page could be needed for operand access also. The worst case involves indirect addressing, particularly uh, where multiple levels of indirect addressing are allowed. Next, I will move to thrashing. Thrashing in computing is an issue caused when virtual memory is an issue. It occurs when the virtual memory of a computer is rapidly exchanging data for data on hard disk to the exclusion for most application level processing. As the main memory gets filled, additional pages need to be swapped in and out of virtual memory. The swapping causes a very high rate of hard disk access. Thrashing can continue for a long duration until the underlying issues is addressed. Thrashing can potentially result in total collapse of the hard drive of the computer. Thank you.